After reviewing analysis, we can go for design. Go to design tab, column design, settings and parameters to customize the settings for design and detailing. In design settings, 0 has been provided for code defaults. Here rebar selection method, fixed bar layout and bar optimization layout. There are flexible options for tie and link pattern, rebar arrangement for columns and shear wall. Here link pattern for columns. Here link pattern for shear walls. We will choose these two options for short wall and long wall. We can select preferable rebar size, spacing and other options. Same thing for links also. We will go with default parameters. Here are the general settings for detailing. We can choose detailing preference as per our regional practice so that construction work can be convenient. First we will go for batch design, that means design all. Then we can go for interactive design individually with failed section. The sections which will not pass, that means which will fail, we will select these sections and we will go for interactive design. Design completed, close. Now here we can see most of the columns failed. We will select one by one failed member to check and customize so that they can pass. See the column section parameters. First we will try to maximize the rebar and go for redesign. If it passes then okay, if it does not pass then we will increase the section size. Now click on interactive design. It will redesign the column. See warning message, still bars cannot be selected, section size insufficient. So section size to be increased. Here we can see the diagrams. Here we can see the report. Now we will increase the section size and we will rearrange the rebars until it passes. Now run interactive design and check it is not passing yet. We will rearrange the rebars again run the design. Now passed. We can edit links as per our preference. Click on OK. For section size changes, it may say that the analysis will be invalid. We will continue design optimization using old result because old analysis not deleted, just invalidated for section size changes. We can copy rebars from past member to the similar sized column section in other floors or in other location of the building. Green equal symbol helps to find similar section where we can paste rebars. After pasting bars, immediately redesign will be done. We can make the section same for the columns at same position in different floors. We will change the dimension to make similar section for all the columns at same position in different floors. Then copy rebars from past column to other columns following the green equal symbol. Now see all C1 columns in different levels passed. We can see column details elevation drawing from this option. In this way we can finalize or design all other columns and then we can go for shear wall design optimization. Automatic containment help us to arrange the rebar easily inside the shear wall. We will rearrange the rebars by increasing the number inside the web of the core wall. Then check design. It is failed. we will increase the number of bar again, increase the bar from auto containment. We will use this option for our customization. Then check the design again. Now it has been passed. Click on OK. We can copy this rebars to other floor shear walls. Instantly other floor walls will be redesigned and we will see walls as passed in other levels. In this way we will optimize our wall design very easily in this software. We can see detailed drawing, elevation drawing from here. See the drawing for the wall generated very nicely. These drawings can be generated in CAD format using Prota details. We can continue our optimization for other core walls. We are following same procedure. See here. After rearranging, run the design. Now it has been passed. We can copy these rebars to other core walls at a single click like this. This way we have finalized all the columns in our design. Now we will go for beam design. Click on story beams. We can go for base mode for all stories, or we can select specific story for beam design. Initially I will go with all stories and reselect all bars for new design. Calculate. Process completed. Close. At level 1, that means PV1, PV2, PV3, PV4, and level 2, 1B1, 1B2, seems all the beams passed, only one failed. Before going to design beam, we can check setting and parameters. Here we can choose our minimum and maximum diameter of our beams. We can select 16, minimum, maximum 20. If required hanger bar, we can make it 16. Steel bar properties. Top rebar spacing, that means in the beam section, in top layer, if we provide 3, 4, 5, 6 number of bars, then according to the width of the beam, it will calculate the spacing and it will show if it is less than this one. This spacing should be provided because the aggregate should pass through the rebar spacing. Okay. Wave steel, this is for torsion. Wave steel rebar, we can choose 12 or 16. Initially I am going with 12. Link properties, support, maximum support link spacing, here we can make it 150 and minimum make it 100 or 50, better. For span, mid span, we will make it 200 and link spacing step 25 mm. Here concrete cover, here is written 00, that means it will follow the design code provision. Beam end, this is measured from section edge to center of the bar. This one we can keep same as it is. Rebar pattern, here there are some rebar patterns. From here we can choose our preferable pattern. Nowadays bent up bars are not used in beam, so we will check standard pattern 1, 2. Here you can see the rebar layers with the pattern. Pattern 3 having hanger bar, top bar, support top bar, bottom bar 2, support bottom bar, web rebar. 4, it is having top bar 1, 2. In top there are 2 layers for main bars, extra top bar 1, extra top bar 2, 2 layers for extra top rebars. For bottom there are 3 layers for main bar, and extra bottom rebar there are 2 layers of extra bottom bar, and web bar, this is for torsion. 5, 6. From here usually I go with this one, multi-layer pattern 2, because here I will get 3 layer for top main bar, 2 layer for extra top bar, 3 layer for bottom main bar, 2 layer for extra bottom bar and torsional bar. And here curtailment option, default rebar layer 1, it is okay. Default left extension, extend left to lap, it will go up to the lapping length. Here if we choose extend left to face, that means it will go up to the left face. And default right, this same, extend right to lap length, right to face. Here other options are also available. If we need to customize these options, we can do it from here. Beam type, floor beams, span now 2, 3, default rebar pattern 2, this is already selected. If we need to change from here, then after clicking on this, here we can click set pattern as default, that will be set as default. Here steel bar selection, bent up bar, links. Here we can choose the link pattern. Curtailment, here we can choose the curtailment style. Bottom span bar, lap bars outside support, this is standard. Top span bar, lap bar inside support, this is standard curtailment rule. We will keep same as it is. Steel bar 2, bob control, bob means bend of bar, bob control. Here we can customize if we need. Detail drawing, from here we can choose the options for detail drawings. So these are the options, and here detailing option, number of beam elevation per insertion row 3, horizontal spacing between elevation. This is for the drawing options you want to see in the drawing sheet. Okay, click on OK. Now here we will check this beam has been failed. How we can pass this beam, we will see now. Click on this. Here it is showing bars do not fit in the cross section. Click on OK. Click on yes. Here we will see where is the red values. Here it is showing the AS minimum top rebar, AS minimum bottom rebar, spacing of bar top, spacing of bar bottom, deflection check, this one, support links, this one. This is the required reinforcement. Here it is showing top and bottom, top and bottom, top and bottom for all the spans in same axis. or same grid. It is showing the rebar spacings. Here it is 17 millimeter only. Minimum we have selected 25 millimeter minimum spacing, so that should be maintained for coarse aggregate passing during concreting. So it is showing red color, so here we have to adjust. Here top bar 1 first layer, here the software has chosen 4 number of 20 millimeter dia bar. We will make it 2. Then we will add another layer, here 2. This side number of bar, this side diameter of bar. In top of the bars there is 150 millimeter, so as it is 160, so it is showing red color. So what we can do, we can change the setting, or we can increase one rebar to reduce the spacing. Okay, now there is no red color. In bottom also, here we can provide 218 or 316. If required, another layer we can add here. And in support also, if we require extra top bar, then this is the support top bar, extra top bar 2y18. If we make it 16, then it is okay. Here at bottom it is showing -11, that means more 11 millimeter square rebar required here. So here we can add another layer 2y16. Okay, now see 371 millimeter square extra than the required. Here required 634, we have provided 634 plus 371 millimeter square rebar as per our rebar provision. This we can keep as extra bottom rebar, or we can extend this rebar up to the face of the columns. To do that one, select this rebar, then go extend left to face, then it will come up to this, or extend like this up to main bar end, or up to main bar end. This side also we can make it same like this. Okay, so in this way we can arrange our rebars. Okay, click on OK. Now still this one showing cross. We will see what is the issue. Here we will click no, as we have provided manually, or as we have arranged the rebar manually. As per this provision, this is okay. Rebar is okay. It is showing utilization ratio 0.96. That means provided rebars are okay. There another issue we can find out. Here is the beam, 2D view also we can see, side view, 3D view like this. Here are the beam members. We can select the members. Here it will highlight the member. Width and depth of the beam showing here. Beam design parameters. Here we can see the forces, moments and required rebars, top and bottom at 3 station of beam. Okay, here it is showing 5B3 section insufficient. 5B3, here 5B3. So if we increase the section depth, then what happens we will see. Click on OK. The section of some beams along the axis has been changed, 5B3. The following analysis result will be invalidated if you proceed. Okay, I want to proceed because only this beam is having issue. I will check with this same analysis result. Now it is showing passed. So sometimes we need to increase the section size after customizing the rebars. Here we can see detailed drawing. This is the detailed drawing. After finishing all the design, here some additional bars are showing because of curtailment. At curtailment, if we don't want to show this much rebars, we can avoid this section. We can generate this drawing at the end of the design stage using Prota details. Okay, so click on OK. Done. So in this way we can design our beams. If any beam fails, we can try to optimize that beam to be passed. Here some other options are also available. For secondary beam resting on primary beams, we can provide hanger links. Now close this one, save file. Now we will go for slab design. If we click on slab design option, initially it will show nothing because we have not drawn any strip for slab. Now we will draw strips for slab, then automatically slab design will be done. Press Ctrl to draw strip line straight. Boundary edge condition must be selected properly during strip generation. Initially, as we have selected edge condition at start beam and at end beam, we will finish strip generation for similar edge condition. Now press ESC and change the end condition with at start cantilever and end cantilever. Here this is wrong because in between there is stair opening, so slab edge condition must be changed. Delete the strip. Now select edge condition at start cantilever and at end beam. Then draw the strip. Now select at start beam and end cantilever to draw another strip after the stair opening. Similarly, we will do this in vertical direction. We must be careful selecting the boundary edge condition for slabs. Now click on slab design option to get strip result and check design status for all the slabs in a single click. As we are going to design this floor, so we will unmark all story option. Now done. We can see the utilization ratio. We can see the settings. As we said, rebar pattern can be changed from setting center. Close. Individually, slabs can be designed and reviewed by interactive design option. If we customize rebars in interactive design mode, we can just click on update rebar option to update all rebars. Here I have not customized any rebar, so keeping same as per auto generated detail. Now we will go for stair design. Floor wise, both stairs are available in the list. For the design process, click on base mode to design all the stairs. Design completed. We can check stairwise the rebars in different stations. We can check analytical diagrams for the stair for different load combinations. We can check stair drawing from Prota detail. Open Prota details. From here we can generate stair only and we can check the drawing how it is coming. See here, it is coming like this. with bar bending schedule. Now we can generate full project drawing from Prota detail by clicking on auto generate drawings. We can customize the drawing list which we want to generate or which we don't need to generate. Now click anywhere in the white sheet, all the drawings will be generated. Column detail shown in plan like this, slab details shown precisely, and here we can see precise column schedule with shear wall schedule, and here is beam section details. Here we can see stair details for all the floors. And Prota detail library offers us various structural member design individually like retaining wall, scaffold, pad footing, swimming pool, pile cap, corbel, etc. Thanks for watching. Stay tuned for more upcoming tutorials.